Alright, so I'm Matthew Ewan, this is Tyler Moy, and Bradley Porter. And for our idea today, we have a rapidly deployed rigid foam orthopedic cast. So orthopedic casts are used to treat fractures, breaks in upper and lower extremities. Current casts today are applied by sliding a waterproof liner over the skin and then wrapping fiberglass around it. This procedure is moderately long, which takes about 15 minutes in a hospital setting with a trained professional. These casts also have little to no breathability, as there's several layers, and that can prove to be really uncomfortable, as you have to wear them on an average from 3 to 6 months.
The medical need that we're trying to solve is to develop a cast that's rapidly deployable, especially in any sort of setting outside of the hospitals, field use. It's got to be waterproof, durable, and needs to have the same performance as current casts, both strength and impact, and also needs to be comfortable.
Just come back on.
So our solution is a foamable cast that is rapidly deployed. It will have a liner layer over your skin, like current cast. However, it will also have a rigid plastic body that's outside the arm and will be filled, the space between the cast and the arm will be filled with a foam that will give you some breathability and plenty of comfort. For our foam, we have two options, which we are still exploring. Physical foaming, which would be a polymer which has a CO2 gas applied to it, or nitrogen gas applied to it, in which case it will foam up and apply pressure to the arm, therefore immobilizing it. Or we have a chemical foaming process, which a monomer is polymerized with a foaming agent in it, which will cause foam, again, to wrap around the arm and immobilize it.
So we're currently in the research phase. We're probably going to continue this, figure out exactly what foam we're going to use, and then we'll move on to the preliminary testing where we actually construct these casts, mechanically test them to ensure that they're as strong as current casts. The next step would be clinical testing toxicity, to make sure that they actually would work in a hospital setting, or in a medical setting. And then the next stage would be marketing. Ideally, we'd like to market to more of field use, so like military applications, backcountry skiing, sort of applications where it'd be difficult to apply a current cast. That's it.
Great.
What are some of the risks that you see associated with some of the ideas of having that cylinder and then injecting the foam? What are some of the risks that you anticipate?
For physical foaming and chemical foaming, one of the biggest risks would be the temperature, because it is an exothermic reaction. We can find ways to limit this using different different foaming agents and different gases, along with finding polymers which have a lower, sorry, I'm at a loss for words right now, a lower heat at foaming. Okay.
There are also some concerns about some of the raw chemicals that are, some of them are toxic. Ideally, we'd have that be a totally separate sort of container, basically, on the cast. So none of them would be in contact with the skin, and then even the foam wouldn't be in contact with the skin because of the liner.
You said this would be deployed more for field use. Is the intent that this would then, when somebody's able to get to a hospital setting, it would be removed and replaced, or would it serve as the permanent cast for the length of the healing process?
We would like it to be a permanent cast, so it'd be a comfortable use, but we can add a liner, a wire, through wire, or a steel through wire which you pull to easily disassemble the cast and rip it off the arm, so it can be reset in the hospital.
Okay. A couple comments for you is that I thought that I like the idea of kind of a constant pressure that you have that, so you've got that, you didn't really make it clear that you've got an inner line, so you're gonna have an inner liner, if you will. You showed the picture of it, but you should probably show it around a person or something like that, that inner liner. Okay, and that's gonna protect the person, and then you got the outer liner, which is gonna be the outside of the pressure vessel, if you will. It's a little bit lost on the people, those two electrodes that you got sticking up there of how that's gonna be, so you might wanna think of a different way to do it. So I think of a couple of things. People don't care what kind of foam you're gonna put in it. You care, because you're a plastic test, okay? So I think you can get rid of that, okay? I think that you have to worry about overpressure, okay? Because you can go, if you put too much pressure on there and it gets too rich, you're gonna cut off circulation of people, so you better figure out a way so that never happens, because you can't have that. You know, I don't have blood flow to my hand for 45 minutes, it's a freaking problem, okay? So I think that you need to worry a little bit about, a little bit about that. I like the emergency use, and maybe you guys should get some data about their emergency use. I'm involved in National Ski Patrol, and with the National Ski Patrol, you know, they're still using cardboard boots, okay? And you know, at best, some people go ahead and utilize air boots that they blow up and make rigid. And something like this, that way you could use quickly, okay, and very deployably. I think that would have, and I'm sure there's data on there, or for different applications, and maybe some of the people that you want to talk to. Early market data for this sort of stuff is really important. So talking to first care providers, EMTs, fire departments, you know, ski patrollers. You think of what the list is. Go get their input. Okay, would this be a better animal? And having that VOC, that voice of customer, for the sort of things like this is very, very powerful. Okay.
Just to add to Tom, I think the only other thing, you know, has to do with the overpressure from a safety relief. You know, you don't want to have to have, you know, if they overpressurize, remove the whole thing and start over again. So is there a way, you know, can you look at a foaming agent that takes a little bit of time? So if you overpressurize, you can relieve some of that before it hardens. So.
Or it's how much it builds it, okay, because you can do it in the, you know, whatever you go ahead to with the foam bottle is, when it comes out, it doesn't come out at such a force, or you're only going to get like a 10% rise in the material or something like that. You guys just have to think it through.
Yeah, we're also looking at a few relief valves that we can possibly attach to the body to relieve some of the
Cool.
pressure.
Yeah, and maybe in a couple of places, you know, the thinnest part, the thickest part, so on and so forth, whatever's gonna lock it up. But you can't have where you starve, you know, tissue for that. Okay.
Yes, sir.
And then again, get the voice of the customer. Okay.
Okay.
Okay. Cool.
All right, guys, thank you.
Very good.
Thank you.
You did a nice job.
Nice job.
Nice job.
Yeah.